Exercise 42. Let's discuss about dimension 1 or rank 1 Galois representation and continuous chapter. So let me be more precise. Recall that. So let's say T is a Galois representation of JK over ZP, means that we call it integral p-adic Galois representation. Firstly, it is a free or finitely generated ZP module. Secondly, there is a continuous JK action. So where this case some p-adic fields. So usually, for example, finite extension of QP, and JK is this absolute Galois group. Continuous JK action means that this is a continuous map. And so, which means, so the topology here on T is the product topology. Product topology of p-adic topology. And JK is profinite topology. More precisely, what I mean is that so if you're rank 1, then the opens are given by p to the power n ZP. This is the basis. These are the opens. Okay. And if it's rank bigger than 1, then we use product topology. So this is the Galois representation. And the second thing is character. So a character is a group homomorphism. So we talk about characters into ZP star. Multiplicative group of the invertible elements of ZP. A group homomorphism. It's called a character. Okay, then we say it's continuous if it is continuous function. So on the right hand side, the p-adic topology, on the left hand side is the profinite topology. Okay, so this exercise 42 asks you to show that any integral p-adic representation or p-adic representation of rank 1 comes from twist of ZP by continuous structure. So let me explain. You have a rank 1 representation, which means it is of the form some basis, some generator, some basis E. And so representation means firstly as ZP module, it is isomorphic to ZP, so finite generated as ZP module. Secondly, there is a continuous JK action, which means there is a JK action and so this Galois action is trivial on ZP, so this is just ZP linears. Basically, this is determined by its action on E. So there's JK action on T. So firstly, this means this is continuous, right? This is what it means by definition, rank 1 Galois representation, or ZP. On the other hand side, we want to show that it is classified by continuous checkters. We want to say actually there is a bijection, or you can classify those rank 1 by continuous checkters. So firstly, what is this map? First construct this map, okay? So given here's ZP star. Given rank 1 Galois representation, and so by this JK action over T, which induces in particular group homomorphism. So let's say firstly induces a map from JK to ZP, which maps J to its image J of E. So let me remark firstly, this image actually falling to ZP star, because so you have group action, right? This is group action, and so notice that the G inverse multiply with G acting on E by group action. This is J inverse acting on J of E, right? And so this is J of E by definition. It is given by, because this is action, group action on ZPE, so on this one-dimensional vector space, so J of E is again some element. Let me write chi G. Let me simply write with the notation I will use. Okay. Let me write chi G just, okay? Chi G is in, again, ZP. which means, so the action of G over E is some chi G, some element in ZP times E, so that denoted by chi G. That's scalar, and so this would be J inverse acting on chi G of E, and then again J inverse acting on this. So firstly it is ZP linear, this is chi G, J inverse of E, and so by our notation this is chi G, chi J inverse times E. And this is ZP commutative. This is also, you could think of it as this. On the other hand side, this is also, notice this is also 1 acting on E, so this equals E, right? So as element of this one-dimensional, sorry, I'm not talking about vector space, free ZP module rank 1, because this is a free module, so this implies 1 equals chi J inverse chi J, and in particular this times you tells you that, okay, sorry, I'm making a mistake here. So of course I'm not mapping J to J of E, I'm mapping J to chi G. Okay, this is in the ZP star. J of E is in the vector space ZP times G. So this tells you chi G is in ZP star. That's how we construct this map. This is the first remark. So I've constructed a map. Not yet. I construct a map. I construct a chapter. So let me second check. That's not yet even a chapter. Okay. So let me check. This is group homomorphism. So if you have G H, let's call this rho. So rho of JH by definition is chi of JH, right? The question is that is equal rho J rho H, which means chi J chi H. And if so, this is a group homomorphism and become a chapter. And we're left to check it's continuous if the representation is, if the GK action of the representation is continuous. So let's check this. This is easy because by definition, chi JH comes from JH acting on E equals chi JH of E. At the same time, because this is group action, this is also JH of E, and so this is J acting on chi H E. Again, ZP linear. This is chi H chi J, but it's the same as chi G chi H of E. And so this implies this is correct. Let me put this, imply this star is true. Okay. So it becomes a chapter. So what we are left to check is question. If JK action over T is continuous, let me put directly ZP. Then so because to show there is a correspondence, right? Let me call this rho E. It depends on what is this color representation. The rho E is continuous. row is strange. Actually, why not just call it chi? Actually, because we have constructed this map, why don't we just call it chi, which maps j to just chi j? Actually, I don't want to change all the notation, so think of this equals chi j. That's why I choose that notation. Okay, so we want to check whether this is continuous, knowing that this collection or the representation is continuous. So what do? So for any element in the image, let's say chi j, take arbitrary open, then I'm not sure this is the most efficient way to prove this, but let me do it in this way. So I have to construct some open subgroup of JK such that J is contained there, and its image is mapped inside here, right? So construct an M such that chi and M is contained in this open chi j, but let me say I choose some S such that this is contained there. So basically this is chi j plus chi j, this is in ZP star, then p to the power m ZP. Which means this valuation is 0. So this again in this is in p to the power m ZP. So actually, while this is not only contained there, this is p to the power m ZP because chi j is a unit. Okay, so actually you don't have to do that. You just see the same as chi j plus p to the power m ZP. Right. So can you find this? What we do is, so because of the screen is not moving well, so let me just write again here. So we know we have this continuous map. Right. In particular, this is continuous, imply that for any open of some element in the image, it has open pre-image, or the pre-image contains some open, which means open product with open. So in particular, let's take this chi j times E in the image and take open of it. Let's say chi j plus p to the power m ZP times E. So this is the open of it, which means there exists some open contains J, and exists some open contains E, such that the image is mapped contained there, right? Which means by definition chi of nm times pt p. This is actually let me think. No, this is actually 1 times e, right? So this corresponds to 1 plus times e. One plus pt p contained in chi g plus p to the power mzp. Right, this is chi m plus, again, the image of chi is always in the p star. Right, this is contained there. And so in particular, chi m is contained there. So this is in ZP star. It's disjoint with this part, okay? So we prove this. Kind of redundant, but this should work. So what we have done is we prove that we constructed functor in some sense. Given me a rank 1 Galois representation, I can associate a continuous chapter. So now let's say that different representations corresponds to different chapters. Suppose you have the p e1, the p2. So suppose the isomorphism as Galois representation, which means there is a GQ equivalent isomorphism. Let's say, suppose E1 is mapped to alpha E2, and then this GQ equivalent tells you about how is the so let me call this C. So this GQ equivalent will tell you that isomorphism representation corresponds to the same continuous chapter. So CJE1 equals JC1, that's the GQ equivalent, and the left hand side equals C alpha times E2, which is, so this is GQ equivalent and at the same time isomorphism of CP module, so CP linear 2, so this is so C alpha, what am I writing here? So G of E1, this is so this one corresponds to cyclotron, corresponds to a chapter. So let's call this is our T1, this is our T2. This corresponds, let's call it chi1. Let's call it chi2. We want to show chi1 equals chi2, right? So this is chi1 G E1, right? So this is CP linear C1 equals, let me write C1, and then C1 equals alpha E2. On the right hand side, this is J of alpha E2, and then J is again CP linear, so this is alpha J of E2, and so this is alpha chi 2 J E2, and so compare this two, tells you that chi 1 equals chi 2, right? And so, which means that map constructed between representation rank 1 to checker, continuous checker from JK to ZP star. It's injective. Sorry. That's what we show, right? Sorry, so this is true, but because we constructed in this way, we show that continuous GK action representation induce continuous checker. So let's don't change the direction of the arrow. So okay, so our question is, we want to show this is bijective, right? So let's check if this is injective. So which means that if you have two checker, let's forget this for a while, what I discussed for. So suppose you have chi, so you have T1, T2, and this give you chi 1, chi 2, right? If chi 1 equals chi 2, then the question is T1 isomorphic to T2 GK equivariant? So this isomorphism we can construct it by hand. So firstly, the Galois is JE1, chi 1 JE1. This comes from JE2, chi 1 JE2, and this chi 2 JE2, but chi 1 chi 2 are the same. Okay, so let's construct the isomorphism. Let's simply just map E1 to E2, right? Let's check whether this is J equivariant, and this is J equivariant because C J1 equals G C1 because this is C chi 1G. Let's see, the other equal, let's call it just chi. It's chi G1, and so this is chi G C1, which is E2, and on the right hand side this is J of E2, and so it's chi J E2. So this is trivially injective. So lastly, can we show this is surjective, right? Which means any continuous checker comes from continuous Galois representation. So this time what we have to show is that this arrow is obvious. So if you have chi, then you construct representation such that with JK action given by JE equals chi J of E. The only question is when this is continuous checker, does it imply this is continuous Galois action. If it is, then we are finished. We can prove this is surjective. Right. So this is the last thing we have to prove. So to prove this, again, what we have to do is we have to show that JK action is continuous. So let's take any element on the image and take an open of it. Let's say lambda chi j plus p to the power m z p. Take an open of it. The question is, can we find some open content G and find some open of lambda E such that the image through the other this map, let's call it C, is contained there, right? That's what we have to do. So using the fact that this is continuous, in particular, let's look at this chi G. Open chi G, let's take chi G one plus p to the power m z p, for example. Then there exists some m containing G open under chi. This is contained there, right? And then how about I just put here m and I put here nm. Then what happened? So then applying this C, what we got is chi of nm times lambda plus p to the power m z p and then E, right? So the question is, did this contain there? Basically this part. So you could also, because J is inside there, you could also write this as J times this. Right, it's the same thing. And so the same thing on this. So we know that chi G, chi m is contained here. So this is chi G lambda chi G chi m plus something, okay, plus p to the m z p, right? And so lambda chi G chi m, so this is contained in chi G plus p to the power m z p. Which means this is contained there. And this is contained in lambda chi G so lambda is in ZP, so this is again p to the power m ZP, right? And so this is true. We can prove this continuously. This classifies all the Galois representations of rank 1.